Hi, in this video I'm going to be presenting my nomenclature nomenclature unit test. Um, for section A, I chose manganese oxide, and I'm going to be proving that the compound's name matches the chemical formula. So first we would look on the periodic table and we would look for manganese. And as we can see that manganese is in column 7 and oxygen is in column 16. So we can see that oxygen has a charge of -2, that it's in the column that is column 16 has a charge of -2, and Mn has it is a transition metal. But we know what the charge is because of the Roman numeral up here. It tells us that the charge is 6. We would write the formula as Mn6O3 2 minus, or -2. We would then multiply 3x 2 minus, which would equal 6 minus. We would multiply these two numbers because 3 represents how many oxygen atoms there are, and then 2 represents the charge of oxygen. So after multiplying those two, we would then get Mn6O6 minus. We would then need to cross them, which would give us Mn6 minus O6. Now we would remove the charges from both of them. We would have Mn6O6. This can be simplified to 3 and 3 since they are both 6, and this would give us Mn3 and O3. For section B, I chose iron oxide, and for this section we are going to, or in this compound, we are going to be finding the error in the answer, which the answer is Fe2O3. That is wrong. That is not the correct answer. That is why we're trying to find the error in it, and we're trying to find the correct answer. So Fe, we look on the periodic table and we would look for Fe. Fe, we can see that it is in column 8. And then we would look for oxygen, oxide, and we would see that it is in column 16, which gives you a charge of 2 minus. Fe is a transition metal, but we don't know the charge for it. It doesn't say it in the column because it is transition metal. But we would look at the Roman numeral, and it will tell us that it is 2. So then, it tells us that it has a charge of 2. We then write the formula Fe2 plus O2 minus. We then need to cross them over in order to get Fe2 minus O2 plus. Now we have to remove the charges. Now we remove the charges from both Fe and O, which would give us Fe2O2. This can be simplified to 1 and 1 since they are both 2. This would give us an answer, or this would give us the answer FeO. For section C, I chose iron trifluoride. We're trying to find the error in the name. Iron trifluoride is not the correct name, and we're trying to find the correct name for FeF3. So we would look at the periodic table for Fe, and we would see that Fe, iron, is in column 8. And then we would look for F. We would find, by looking on the periodic table, that it is in column 19 or 17, and column 17 has a charge of -1. This would mean that F has a charge of -1, and Fe has a charge, well, Fe's charge is different depending on the charge, or depending on what it is bonded to. So then we would then start out with putting iron fluoride 3 with the charge of 1 minus, and we would multiply 3 times 1 minus to get the answer 3 minus. That would give us the overall charge of fluoride, because fluoride there's 3 fluorides, but they each individually have a charge of 1, and we would combine all of the charges in order to get 3 minus, and we would then come up with iron fluoride 3 minus. We would then add 3 to iron in order to even out both sides. After this, we would then change 3 into Roman numeral 3, which would give us iron Roman numeral 3 fluoride.